Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 4 of Kubernetes Troubleshooting Zero to Hero series, and in this video we will learn what are some of the real-time issues that DevOps engineers face with respective stateful sets and persistent volumes. While explaining this issue, I will cover the concepts such as stateful sets, persistent volumes, persistent volume claims, storage classes, and CSA driver. So this video is going to be very informative. We will learn about an issue. We will learn how to troubleshoot it and how to fix it in real time. So please watch this video till the end. If you haven't watched any of the videos in this series, we have already completed 3 videos, 3 Kubernetes real-time issues, how to troubleshoot them and how to fix them. You can watch the previous videos and you can also get the notes of the videos. If you go to the device folder, you can see the complete manifest that I'm using and also a README file that will help you revise the concepts that you have learned in the video. So you can start this repository, fork it, watch it to get the continuous updates. Okay, so let's get started with the issue for today. So the issue is that there is a developer. So developer has reported an issue to the DevOps engineering team. Probably developer has created a Jira bug request, wherein the Jira ticket developer has mentioned that one of their stateful set application or one of their stateful application, it can be a database or any stateful app, which is working absolutely fine on the AWS EKS cluster, is not working when they try to deploy on the other cloud platforms, such as when they deploy it on AKS or when they deploy it on, let's say, Google Cloud Platform, which is the Google Kubernetes engine, or even when the developer tries to deploy the same stateful set on the local clusters such as Minikube, is not working. So only it is working on the AWS EKS cluster, but when they try to deploy it on AKS, GKE, or any local cluster such as Minikube, it is not working. So this is the Jira ticket that developer has created. Why did developer create that with the DevOps engineering team? Because DevOps engineer is responsible. DevOps engineer is the subject matter expertise with Kubernetes, and probably most of the times they also share the YAML manifest for the stateful set or any Kubernetes resource. Whether or not DevOps engineer has created the YAML file for this stateful set application, when developers have such issues, it is quite common. They create a Jira ticket asking what can be the issue. Now assume that you are the DevOps engineer and you got this issue. How will you troubleshoot this issue? So for that, I have a Kubernetes cluster already. Because I want you all to also practice this, instead of doing it on AKS or GKE, what I've done is I have created a Minikube cluster. Probably you can also create a Minikube cluster or kind cluster on your local machine. Now this is the statefulset.yaml file. So it's a simple stateful set application, a Nginx web application, which they want to create as a stateful set. If you are interested, you can also use a database. It's almost the same manifest and everything, but I'm using a simple Nginx application. So it starts with 3 replicas. And if you look at the persistent volume, so they have attached a persistent volume claim template where they are using the storage class EBS, and all the information is available here. You can also use the same YAML manifest. It is available in the GitHub repository. Now let me do kubectl apply -f sample statefulset.yaml. Okay, so the configuration got applied. Let's do kubectl get statefulset. It said the statefulset web is created, but 0 out of 3 pods are in the running status. Okay, let's try to see what is the issue with the pods. So what we will do, first we will try to do kubectl get pods. Now there is an issue here. We were expecting 3 replicas, but we can only see 1 replica, and that is also in the pending status. So why is that? We will try to troubleshoot further. So we have only this pod. Let's start our troubleshooting. The very first thing that you have to do most of the times is just do the kubectl describe. Kubectl describe pod web-o. So here we have the warning. What does it say? Pod has unbound immediate persistent volume claims, and this is why it is not getting scheduled. So what does this issue mean? So here the issue explains us. Okay, let me clear this. So the issue explains that, so you are trying to deploy a pod through a stateful set, but the pod that you are trying to deploy is requesting for a persistent volume, but it is not finding the persistent volume. Now you might ask me, but Abhishek, there are 3 replicas. What happens with a stateful set is that this is the unique feature of stateful set. It's not same with the deployment. Where in the deployment, if you have any issue, all the copies of the replica, all of them run into the issue. If you have 3 replicas, you will see 0 out of 3 pods running, and all the 3 pods you will see, let's say web followed by some hash XYZ ABC, whatever it is. Similarly, you will see another pod. You will see on the 3 replicas, and all of them trying to get scheduled. Whereas with stateful set, what stateful set does is, even though you have 3 replicas, the second replica will only be created if the first one is successful. Now, because the first replica itself is in the pending status, the second one does not even get scheduled. Only when the second one scheduled successfully, stateful set will start triggering, or the container gets created for the third replica of the stateful set. So that is the reason why we are only seeing 1 pod. If you do kubectl get pods, you will only see 1 pod that is in the pending status. If this one moves from the pending to successful state, you will see the second one in the container creation status. And even if this is successful, then only you will see the third pod. This is the unique nature of stateful set. There is a reason why this happened. We will talk about it in a different class. But for now, let's go back to our issue. Okay, so stateful set is trying to create a pod, and this pod is looking for a persistent volume, but it is not getting the persistent volume. Again, the question is why? So to understand this, let's take 1 minute to understand the workflow of the stateful set. So what usually happens when you create a stateful set and request for a persistent volume, in the stateful set definition, as a developer, right? What a developer does is, developer in the stateful set will mention a persistent volume claim. So as the name itself suggests, persistent volume claim is a claim request that this stateful set is making, where in the claim request, the stateful set says that I need 1 GB persistent volume. Now, depending upon the persistent volume claim, usually every persistent volume claim will have a storage class. And this storage class, using a provisioner, will create a persistent volume. So this is the workflow. A stateful set will have persistent volume claim. Persistent volume claim will have a storage class. Storage class talks to the provisioner, and provisioner will create a persistent volume. Abhishek, can you make this easy for me? It's very complicated. For sure. Let's take the example of AWS. Because the developer mentioned the stateful set is working fine on AWS EKS. Let's take that example. Now, when the developer has created a stateful set on the AWS EKS platform, if you look at the statefulset.yaml file that developer shared with us, right? If you scroll down, there is a volume claim template. And in the volume claim template, which is the persistent volume claim, the developer has mentioned that the storage class name is EBS. What does that mean? So here the persistent volume claim has mentioned that the storage class is EBS, which means in the AWS environment, you have EBS, you have let's say EFS, you have AWS FSx services such as NetApp, ONTAP. So there are so many storage services on AWS. When you create a stateful set, or when you are requesting for a persistent volume, how will AWS understand, or how will EKS understand which out of this it has to provide you as a storage service? Should it provide you EBS? Okay, you are requesting for 1 GB, right? Here you are requesting for a storage of 1 GB, but are you requesting that 1 GB through the EBS service? Are you requesting that 1 GB using the EFS, or any of the AWS FSx services such as NetApp, ONTAP, or the other things? For that, in Kubernetes, you have something called as storage class. Okay, so the stateful set should explicitly mention what is the storage class that they are looking for. How do they mention? They mention that in the persistent volume claim. So this is the persistent volume claim template. And when this is mentioned on the AWS EKS, there will be something called as EBS provisioner. And this EBS provisioner will actually create a EBS storage, which can be used as persistent volume by this stateful set. So this is the workflow. Now, why was this working absolutely fine on the AWS EKS? Because all the provided details are correct. So developer said, I want a stateful set. I want 1 GB of storage with the storage class as EBS. So it worked fine. But now when the developer is trying to deploy this on Minikube or AKS or GKE, it will fail. Because if you do kubectl get storage class, what are the different storage classes on the AWS EKS? If you do this command, you will find EBS, you will find EFS, other things. But this is my Minikube, and here it says that the storage class, only one storage class is available, that is standard. So what is the Minikube workflow here? In terms of Minikube, if I try to draw this parallelly for Minikube, how it looks is, whenever you create a stateful set, within the stateful set, you will provide a persistent volume claim, and the persistent volume claim, if it has to run, if the stateful set has to run on Minikube, the persistent volume claim should have the storage class name as standard. And when you put this within the Minikube, there is a provisioner. You can just run this command kubectl get pods -a on your minikube cluster. You can see that by default there is a storage provisioner. This is the standard storage provisioner. On AWS EKS cluster, you will find EBS provisioner, you will find the EFS provisioner, etc. But here there is only one provisioner, which is the storage provisioner, and the name is standard. So if you provide to get this stateful set working on minikube, in the PVC section, mention the storage class name as standard, and that will talk to this particular provisioner, and it will create a persistent volume for you with 1 GB. Similarly, if you want to do it in Azure, you have to use maybe blob or any kind of storage that you want to use. So the storage class will change. Let's try it now. Now, if you do, let's delete this first, right? So kubectl delete -f sample statefulset.yaml. I've deleted it all. Let me go to the same file. Now I'm trying to fix this issue for the developer. So I'll just say, instead of EBS, standard, and let's do apply. Let's search kubectl get pods, and let's try to watch the status. Okay, it says it is in the pending status. Did we provide the right spelling? Let's see. Sample stateful set standard. If you do kubectl get storage, so this will change for any Kubernetes cluster that you're using. Standard, I think the spelling is also good. Let's try kubectl get pods and watch. Okay, let's see what is the issue. Describe again. Let me describe. Okay, I understood what is the issue. Basically, when you try to delete the stateful set, sometimes, or the behavior is not standard, it does not delete the persistent volume claim that you have created. So you have to explicitly delete the persistent volume claim. So let me do that. kubectl get PVC. Let me delete both of them here, the persistent volume claims that I have. Okay, I've deleted kubectl delete PVC, both of them. So this is the behavior of stateful set, where persistent volume claim as well as the persistent volumes also have to be explicitly deleted. If you delete stateful set, it will not delete them. Now let me apply again. kubectl get pods and watch for the pods. Okay, first one is in the running status. It said only 1 out of 1. Okay, there are 3 replicas. kubectl get pods. The second one is getting created. Like I told you, once the first one is in the running status, the second one gets created. And once the second one is in the running status, the third one will also get created. If we do watch, see, the third one moved to pending, container creating, and third one also got created. This behavior is unique to stateful set. This is not same with the deployment. There is a reason behind it. Why is this happening? Just to give you an overview, let's assume you are dealing with databases. You have a primary database. When you have 3 copies, one database will be your primary database, which is reading and writing. The other 2 will be your backup, or if this is your active database, these are your passive databases, where these pods are just reading, and this one is the active pod, which is reading and writing. What is the point of starting these 2 without starting the active database? So this is just a rough example. There is a reason behind why stateful set starts all the replicas only if the previous one is successful. We'll take that in a different class. But for now, we saw how to fix this issue. Now, all the 3 pods are in the running status. What did we fix? We just made sure that when you are transitioning from AWS to AKS or AWS to GKE, you have to make sure you provide the right storage classes. If you don't have the right storage class, then your Kubernetes stateful set will not start. But Abhishek, what if, like, you said that on the AWS cluster, you have EBS, right? On AWS, you have EFS. So for these things, there is a storage class that is available and there are provisioners that are available. But what if I want to use an external provisioner, or I want to use a persistent volume from external storage service? So there comes the concept called as CSI driver. Okay, so what is a CSI driver? Basically, there are some default storage services that Kubernetes already knows. So the code for this storage provisioners, if you are talking about EKS, EKS already has some storage provisioners like EBS. It already has a storage provisioner like EFS, which are the default AWS storage services. But what if I want to use on the EKS cluster some external storage service? Let's say I want to use a NetApp storage service. Okay, NetApp storage service is not native to AWS and I want to use it. What should I do? So you don't have to do anything. The NetApp storage provider, they will provide a CSI driver. You have to install that CSI driver on the EKS cluster. CSI is basically container storage interface driver. They will provide you this driver. Once you install that on the EKS cluster, then the driver that you have installed, it will act as a provisioner or talk to the provisioner, and that provisioner will create persistent volume on your external storage service such as NetApp or any other thing. So slight modification in the workflow. Now, when you want to create a stateful set with an external storage or not the out of the box ones like EBS or EFS, you have to create a stateful set. In the stateful set, you have to provide the persistent volume claim template. In the persistent volume claim template, provide the storage class. Okay, in this case, the storage class can be the NetApp storage class. But additionally, what you have to do is you have to install the CSI driver. Their CSI driver, of course, you will not have to do anything with respect to writing the CSI driver. Just go to their documentation. You will find a Helm chart or you will find a Kubernetes operator that they provide. You just have to install it on the EKS cluster. That CSI driver either acts as a provisioner or talks to a provisioner, which will create the persistent volume. So for external storage services, this is the additional step. If you are using the native storage services directly within the storage class itself, you can provide EBS as the storage class. It will talk to the EBS provisioner and create the persistent volume. Similarly, if you want EFS, which is again a native, so it will also talk to the EFS provisioner and create a persistent volume. So CSI driver is a little extra or additional concept where you have to install that driver. I will do a dedicated video for stateful set where I will create a stateful set with enterprise. Now I'm already working on this, but it will take some time because I want to do a stateful set, a MySQL database with enterprise storage solutions such as NetApp, where I will be using CSI driver, I will be using the NetApp's OnTap solution and show you how to deploy that on EKS. What are the performance benefits that you are going to get compared to EFS or EBS. But this is going to be a very much real-time video, and the AWS billing for this is also very high because the NetApp solution by default comes with 1 TB storage. So it is also going to charge a lot. So I'm trying to take a look at how to do it. I have some AWS credits. I might be using them. It will take some time, but you can expect this video on the channel, which is going to be a very enterprise level project. Now, I hope this particular video explains you how to solve the issue with respect to stateful set persistent volumes when the issue is with respect to the storage class. Thank you so much for watching the video again. See you all in the next one. Take care. Bye-bye.